Communicating with sound involves shaping sound in some pretty sophisticated ways. What do I mean by this? Consider for a moment color. We can distinguish millions of different colors. And the same can be said of sound. Just think about the rich variety of sounds that come from musical instruments, or the rich variety of sounds of typical human speech. Communication with sound also involves being able to project sound signals over some distance. To communicate, you have to get a sound from transmitter to receiver. The physics of sound has some important things to say about this. Long wavelength sound, for example, can project quite far, while short wavelength sound can only project short distances. Large animals typically produce sounds of low frequency. Small animals, in contrast, can only produce sounds of high frequency. This shapes the biology of communication in some significant ways. Elephants, being large, can communicate over much farther distances than can, say, small bats. As you watch the videos to follow, I want you to keep three things in mind. First, I would like you to be thinking about how sound can be shaped in ways that can encode information. Keep in mind that we do this effortlessly in speech and music. What are the broader implications of this ability? Second, I would like you to be mindful of how sound projection is influenced by frequency of sound. And I would like you to be mindful of the physical constraints of body size on sound production and projection. Finally, and third, I would like you to reflect on how sound can be used as an alternate form of vision. What are the common elements of light and sound that enables them both to be used to construct visual maps of the world?